Let's talk about dye capacitance today in IBIS model buffers. Now, the dye capacitance in IBIS model buffer represents the dye capacitance in your overall I/O buffer. And when we think about dye capacitance, we're really more concerned about the input capacitance versus the output capacitance. So if you think about your system level simulation, we have a driver and a receiver, and you're driving a signal through your interconnect, your transmission lines, your PCB, we're really concerned about how that waveform looks at the receiver. And the input capacitance of the receiver plays an impact on how good or bad your signal quality is, right? So the bigger the input capacitance is, the more opportunity there is for the signal to ring and reflect back. Now in an IBIS model, you enter in this dye capacitance, and it's a keyword called Ccomp, and you enter in a static value. Now the question is where do these values come from? So when someone is making an IBIS model, how do they come up with these values and where do they come from? Now most oftentimes, most IBIS models are actually generated from SPICE models. So you run different simulations under certain test loads and you generate all this IBIS data. And you do the same thing for this dye capacitance. Now remember, the dye capacitance, the Ccomp value, is only supposed to be the capacitance of the I/O buffer. It's not supposed to include the package capacitance. So sometimes you'll find that some vendors will actually put the package capacitance in as the value, giving you a much larger input capacitance than you expect. So that's something that you should check for in your quality process flow. Now getting back to how is Ccomp actually generated or extracted through simulation, there's typically two types of methods that are used. The first one is a time domain method, and this is essentially doing a time domain sweep on your I/O buffer and looking at how your capacitance varies over time under a set load condition. Now the other way you can do it is you can do a frequency sweep. Now remember, as we all know, that capacitance is frequency dependent. So as your frequency changes, so are your capacitance. So now you're probably thinking, well, now I can have a different capacitance value at different frequencies. And if the IBIS specification only allows me one value to enter, what value do I enter in? And that's a really good question. And the short answer is essentially that most model makers will choose the right capacitance value essentially on the data curve, say, of capacitance versus frequency, where it levels out, as long as it's within the frequency range of the switching, maximum switching frequency they want of the IBIS buffer model. But the real key here is that you really need to do some simulation and correlation in order to validate that your Ccomp value is the right value to use. Now you can also use lab data. Some IC vendors will actually go and measure the dye capacitance and abstract out the package capacitance to show what that value is under conditions as well. So what's important to know is that in the end, is that IBIS allows you to have one value for this dye capacitance. It can include the package capacitance, and there's different methods to extract to this value, and that's okay, but you really need some correlation data in order to have a high level confidence that this capacitance value is correct. Thanks for joining me today for this coffee break video. I hope you enjoyed it. If you have any questions or feedback, or if you have a topic that you'd like me to discuss next time, send me an email at tim@signalbytestech.com, and be sure to join us online at signalbytestech.com. Sign up for our newsletter, be notified when we do another one of these videos. Now, I'm going to have another cup of coffee, and it's probably time for you to get back to work. I'll see you next time.